technically is letter A, but if you guys remember, I've kind of been trying to hint at this quite a bit. The pictures of the vectors aren't necessarily the most important thing for you guys to take from section 6.3. Remember how we talked about yesterday, especially in like this tension-y problem? Like, yeah, there's this whole picture going on. Besides just pulling out what we needed, we went to components ASAP. We went to components as quick for that. We could have done stuff with the components like as quick as possible. We went to components. Another problem. I said go to the components as quickly as possible, right? It is part A, and in your homework you might have one where it says to draw a figure or visually represent what's going on. We really just want to get to components. So look at what B and C both tell us to do. Write the velocity of the wind in the jet as a vector. And, well, this one says velocity of the jet relative to the air. Basically, it's saying disregarding the wind, if you want to put it that way. But the velocity of the wind, the velocity of the jet with relative to the air in component form. So what are they even telling us to do, like really, really soon? Draw a picture, sure, good, but really just get them in components. So do you guys remember, and hopefully from your homework, and I know the bulk of homework was done 2 nights ago, right? Hopefully. But remind me, and this comes from that really important yellow box that hopefully everyone's going to put on their reference page. Wind is V, according to how I did it, and jet is U. How do we get components if we know magnitude and direction? Cosine and sine. Cosine and sine. Good. So for the first one, it's going to be cosine. Think cosine goes with the x, sine goes with the y. So for the wind, what do we have? 60 miles per hour, right? Good. 60 cosine of 45. And then 60 sine of 40. Oops, my A's in the way. Sorry. Sine of 45. Okay. Letter C says do the same thing for the jet. So you guys use the same pattern. Good. Matthew's saying it up here. You guys see the speed or the magnitude of the jet would be 580. Except what's his angle? 332, yeah. Okay. B and C just said, hey, get the components. We're like, sweet, we want those anyway. What's letter D say? Yeah, the ground speed. So if you guys look up here, the velocity of the jet relative to the air is the ideal, is in a sense, without getting too technical, what and where the jet is trying to go, trying to head. Like if the wind was still, what the jet would be doing, how fast it would be going, and in what direction it would be going. That's what's going on in letter C. But letter D is actually asking what's the true speed, the ground speed, the true speed of the jet. The wind is going to throw it off a little bit. The jet's trying to go, in a sense, this direction, at this bearing, this speed, and the wind's going to throw it off a little bit. Maybe even slow it down a little bit. So they're asking, okay, what's the overall result? On the ground, if you're trying to see what is the jet actually doing up there, well, the wind's having an effect. Pause. Hold on, Joe. So letter D, we could think of it as magnitude. What is the magnitude of the overall result? And then at letter E, what is the direction of the overall result? Now, Joe, you were saying ground speed. And I know what you're saying by ground speed. I don't think that's truly what they're asking in letter D. Because they're not saying ground speed, they're saying with respect to the ground. So if there's someone on the ground looking at the jet, not if the jet was on the ground.
No, ground speed just means like how fast it moves relative to the ground.
Oh, sorry, what was your question then?
My question is, if you're flying that direction, you're going to get from
Hmm?
Oh.
Why not?
Because it's not the right angle.
Okay, you can look it up and Google it if you want. But Miami is
Yeah, but
south. Just in general.
it's like this.
Okay, then Joe, feel free to Google it tonight, okay? And we can talk about it during lunch or nutrition. So then as we try to do letter D and E, if you guys notice, both of them are asking for magnitude and direction of the result. What is the overall? Well, guys, hold on. What do we do in math with vectors to try to put them together? What operation do we do? System, you're thinking mathematically, like putting together multiple equations. It's a little bit simpler than that. It actually goes back to the very beginning. Very beginning. Like right after we watched the Despicable Me clip, very beginning. Do you guys remember that we had multiple vectors and we were talking about the overall result? We had multiple vectors, overall results, multiple vectors, overall results, multiple vectors, overall results. And this was the easiest one to see. What operation gets me the overall result? Simple addition. Now, it looks a lot more complicated when you have angles. It looks a lot more complicated when you have triangular or even more complicated vector diagrams. But at the end of the day, how or what are we doing to vectors to get the overall result? Adding them. So guess what we get to do way over here when we're talking about a jet that's going at a certain bearing, trying to go from Miami to Seattle. The wind is pushing at a certain direction, etc., etc., etc. What are we going to do? Just add. Now wait a minute. Is adding going to get us magnitude though? Or is it going to get us components? For D and E, we need magnitude and direction, but guess what happens if we just do our simple addition in our calculator? We get components. So we're going to actually have to add, which we're going to do. We're going to have to add down, but then once we have the components, aren't there special formulas to get the magnitude and get the direction? All right, I need people with their calculators quickly to throw this in. 60 cosine of 45 plus 580 cosine of 332. Remember, before the test, which we still have a couple more sections, but before the test, you need to make sure that your calculators are working. Before the test, you have to make sure your calculators are working. So let me double check too. I think I accidentally went back and, not accidentally, for calculus I went in radians. Let me go back in degrees. What, Selma? Oh, no, you're good. 60 cosine 45 plus 580 cosine of 332. Yeah, I got that too. Did anybody else get that with me in Matthew 554 point? Then doing the same thing but with sine. And guys, I'm totally lazy, so I'm going up and stealing this entry, and all I have to change for this one is just put in sine instead, right? It's up to you. Maybe it's faster for you to type the whole thing over again, but I'm a lazy bum. Yep, I got that too. I gave 229.87. Now careful. What are these called again, the side carets? Yeah. So we have the components of the overall result. We have the components of what's happening with the ground, not the ground speed, sorry, the airspeed of the jet plus the wind. But they actually want the speed, aka the magnitude, because that's what the speeds were up there, and the true direction of the jet. So how do we take components and get magnitude, guys? Yeah, what formula? Pythagoreans. The long story short of the square root of a squared plus b squared. Can I name this guy A and name this guy B? Just to be lazy. Once again, I'm going to go throw it in my calculator. So the square root of, go steal the first number squared, plus go steal the second number squared. Ooh, put the second number in parentheses though, because he's a negative, right? Remember how we talked about yesterday, if you don't put the negative number in parentheses, we'll get in trouble. I'm getting 600.29, but I want to see what you guys get. You guys agreeing with me? Double checking? Good? I know. Okay. But how do I do direction? So So far, guys, so many important formulas. If you don't have them on your card, you're kind of screwed on the test. Unless you have them memorized. But components, magnitude cosine angle, magnitude sine angle. Components of another guy, fine. Magnitude cosine his angle, magnitude cosine his angle. Sorry, sine his angle. How do I put different forces or vectors together? You add them. Components is the easiest way. Avoid all the geometry mumbo jumbo. How do you get the magnitude from the components? Pythagorean theorem. How do you get the direction? Okay, what do you guys remember, or what are you looking at in your notes? Opposite over adjacent. So you can say opposite is the B, over adjacent is the A. But who's opposite over adjacent? What trig function? What second trig am I doing? So if I do second tangent of B over A, which is that negative 229 guy over that 554 guy. Anybody else getting negative 22.51? Hmm, 0.52, I think. But positive. Not positive, sorry. It is negative right now. Do you guys remember what I said? Wasn't it yesterday when we were grading about the angles that they want you to give? I think that might have been your question, Tyler. Yeah, sometimes you're in a different quadrant and you need to add 180. And sometimes it's a negative one in your calculator, but there was one yesterday. Didn't we have to add 360 to one of them? Because it was negative, but then we added 360 to make it positive. I think it was like negative 45 degrees. I forget what problem it was. But the calculator gave us negative 45, and then we added. Remember I added wrong? I did 325 instead of 315. It was in grading homework. It might have been the previous problem, was it? No, we didn't find an angle in that one. Not that one either. No, I think it was one of the homework questions you guys had. It's on the video yesterday, though. But long story short, a negative angle they don't want. So we have to ask ourselves, are we adding 180 or are we adding 360? Okay, it's bearing. Bearing is weird, remember? It's bearing. Bearing is weird. Where did I start drawing my angles from up here, guys? 330 degrees wasn't down here. I started from North Star. I started from north. So 330 was way over here. So question, negative 22.52. If I was to move my wind, and my wind actually should be a lot smaller, because if this is 580, that's not 60. That's like 100, 200 something. I need to probably make it smaller. But at the end of the day, we could say this is our overall. Yeah. So negative is actually fine. Negative is just going the opposite direction than the normal direction. Negative is okay. The location is great. It's just a negative number. So they're going to want us to add 360 to make it positive. 180 only if you need to get to a different quadrant. 180 is only if you need to get to a different quadrant. So actually we're going to add 360. Our location is fine. Negative a little bit is exactly what it would be. And it ended up being, what, 340? No, 337.48, yeah. And that's our true direction. And then our true magnitude. And we should label the magnitude. We're acting like an airplane instrument just because we're trying to keep it simple for our perspective. Okay, let's go ahead and peek at then, because didn't you guys have 4 word problems last night? 4? 3? 3? 4? Okay. How many of them were tension? 2. How many of them were on a slope? 1. Oh no, my pictures are gone. We should sue. Let me see if I have them in my notes. I totally don't. That's all right. Guys, let me pull up the homework answers, because if you guys remember yesterday, we stopped grading because, well, we stopped at the word problems because we hadn't gone far enough. So let's go ahead and get those evens up really quickly. Let me get the pictures up. I forgot that my book hates these word problems in the sense of doesn't show them. Didn't we have any evens right there at the end? 96. But the nice thing is, you know what, from the math, I totally know what kind of problem 96 was. It was a guy on an incline, wasn't it? How do I know that? Because of the triangle I made you take a picture of yesterday. Because of the triangle I made you take a picture. Remember something on a slope? Remember there was a special picture that said gravity, which deals with weight. Gravity combined with weight. It's okay. We'll just wait. There was a force. Mouse, if it was underneath the box, would be squished. We have what's going against the slope too, but we didn't really give it a name. We had thing about force to pull or force to keep it where it is, force to keep it from sliding. But then we also had this guy, which is an angle. And the ironic thing, it's actually the exact same angle as the incline, as how steep the slope is. So how did I know this problem came from this triangle? Well, because sine is always what we use for opposite over hypotenuse. Sine is always what we use for opposite over force, weight, angle. Hey, that's how I... Picture important to have on your reference sheet? But once you had the picture down, all you had to do was take what they gave you, which was, oh, the force to, I don't know how they put it, the force to keep it from sliding, the force to pull it up. Probably the force to keep it from sliding. Is 600, the angle is 14, so it was as easy as long as you knew your formula, plugging and chugging. So you had sine of 14 is equal to F, oh, we know that, is 600. All over W. Now, guys, they rearranged the formula first and then plugged in. That's fine. You could rearrange the formula if you want to. It doesn't really matter. Or you could just solve it the way it is right here after plugging in. But either way, divide by sine of 14, you end up with your 2,480.1 pounds. They said approximate because they rounded. Whatevs. But I think that was only one of your word, well, we already know there were 4 word problems. That's only one of them, right? The rest of them were odds. So let me go ahead and, just because my pictures aren't showing up very well, they aren't showing up at all on this page for whatever reason, let me go run and see what CalcChat has as far as diagrams so we can try to use it. Nope, that's not him. Where are we? We're 3, right? There we go. We are in chapter 6. We're in section 3. What was one of the other, the first word problem? Was it 85? Cool. 85 wasn't too bad as long as you took, was this the tension one with the pulleys? And there's like a little cable here? Oh, it's not the pulley one. Let me look at it real fast. There was a pulley one though, wasn't there? 463. 85, oh, was the chain. My bad. Okay, 85 was the chain. For number 85, I'm just going to put him over the side if I can. Squish him in just a little bit. Can I squish him in? Yeah. Okay. Isn't that right? So then he had one working in this, and you had one working in this direction. In a sense, you could call this guy U and then this guy V. Told you this one, did they tell you this one was 300? And they told you this one was 125? So how on earth did they get their little equations over there? Wait, pause. What are they called if they're using I's and J's? No, components are the they are using unit vectors. What's the name? Linear combinations. Okay. They're just writing them in linear combinations. But how did they do it? They used 125 and 45 degrees for V because that one is at an angle, right? This part of the chain. So I have 125 as my magnitude, 45 as my angle. What did they use for U? And 0 degrees. So you guys might not have realized it, but you literally could have done our same components. They did. They did magnitude cosine of angle, magnitude sine of angle for V, and they did magnitude sine of angle But what happens when you do 300 times cosine of 0? 300 sine of 0. Cosine of 0 is 1. 300 times 1 is 300. Did they have an I for the first component? Yeah. But then what happened with sine of 0? It's just 0, which is why there's only an I, not a J. So they plugged into the formula. I wanted you guys to see that, even if you were looking on CalcChat. They plugged into the formula, 300 cosine 0, 300 sine 0. And once you have both of your, well, these are linear combinations, all you got to do is put them together. So putting them together, they add. So they added the i's together. They added the j's, well, 0 plus. They added the j's together. And then, guys, do you see them using their formula of a squared plus b squared under a square root? Yes. Do you see them using their tangent inverse of b? Well, b over a? Well, they didn't show the tangent inverse, but that's what you would use. Joe, what's up? Oh, yeah. Thanks for the heads up. And just seeing the answer, guys, when you went into your calculator, it would have been perfect. There was no need to add 180 or 360. It wasn't a negative angle, and it wasn't in the wrong quadrant. Which you might be thinking of the wrong quadrant. If you went, I don't remember what the picture exactly looked like, but if you went and you put your vector together to make the picture, I just did a lot of arrows in all the same color. I apologize. Hold on. Let's change this to be something else. Hi, I want you to be blue. Now it's black. There we go. Okay, if we take this guy and if we move him up, because remember, vectors need to work in progression. There's a sequence to them. And then if I try to connect, remember what you're finding is the magnitude, the overall magnitude, and the overall angle. So 12.8 was fine. I didn't need to go in the third quadrant or the fourth quadrant or go a different direction. So I just kept it. Joe, what's up?
Yeah, I'm just curious about like the angle you get on the calculator. Sometimes it's like off. How do you determine it?
It's not off.
I know it's not off.
What it's doing, remember real quick, tangent inverse in the calculator, because of the programming, you're only allowed to get one answer. And so tangent inverse only looks in quadrant 1 and quadrant 4. Tangent inverse technically has a restriction because it goes between negative pi over 2 and pi over 2 alone, which means, we're doing degrees now, sorry, negative 90 and 90. But in real life, we don't just go 90 and negative 90. First of all, what we were talking about is if your calculator was giving you a fourth quadrant angle, whether it's bearing or whether it's normal, if it was giving you like negative 37 degrees, physics says we don't like negative angles, go positive. So if you're okay, if your vector really is in the fourth quadrant, that's good. You just should add 360 to make it positive instead. So we would add 360 for this one. But let's say your vector was over here in the second quadrant. Sadly, your calculator can't do that. It only looks here and here. It only looks here and here. So let's say it goes ahead and finds me negative 42 degrees. I'm making up numbers completely. But negative 42 degrees. But your vector's up here. What do you do to use your calculator answer to get to the correct answer? Add 180. So Joe, if you're in the wrong quadrant, add 180. Just your calculator got you as close as it could. Add 180, now you're good. If you're in the right quadrant and it's negative, add 360 because it doesn't like negatives. Is that cool? Yeah. We did 85. We looked at 90, whatever it was. What one did we miss? 91? 91. That was a tension one with like a weight. Oh, sorry, still section 3. Thanks, Matthew. You can tell I don't use CalcChat a lot, yeah? There we go. Okay, with this picture, not that picture. There we go. Quick clarification from yesterday. Joe came in and we talked it through a little bit, so I understood what he was asking. I was talking about the cranes lifting the box, but actually according to the picture, and this one too, the tensions on the cable, there's like a pulley system, there's a pulley system. Okay, yeah. They're not lifting it anywhere. There's probably like a chain going to it, right? Good. Some sort of weight. Keeping it suspended. And as you keep it suspended, have you guys ever had to do, I don't know, usually PE teachers love to do this, like have you hold a weight and just keep your arm there?
Yep.
Well, it's so easy for a while, right? You're like, oh yeah, no big deal. And then you're like, oh, oh, oh. And they're like, nope, keep it. And you're like, ah, right? Okay, why? When, for instance, in these examples in the crane with the box, is there anything going on as you're holding something suspended?
No. It's just
There's no work happening because it's not moving, but are there tension? Is there tension? Yeah. And specifically when you have like more than one direction, whether it's a chain, whether it's two different cranes, when you have it being upheld or suspended by multiple parts, there are multiple tensions. So all that isn't moving, it's actually just being held there, but there's still definitely tension at work as it's being held there. So what it tells us in the picture is what, 50 degrees, 30 degrees? 50 degrees, 30 degrees. You could go ahead and talk about like these as different vectors. Do they give it names? A is U, and he was the 50-degree one. Okay, so we can call him U. The other guy is V. There we go. The weight is 2,000? There we go. You guys might not have known why they were throwing in random negatives everywhere. Some of you might have. You've been like, oh yeah, makes sense. But others of you are like, why are there random negatives everywhere? Remember yesterday with the cranes, I said that we didn't want, no, the tensions, sorry. Yeah, that was the cranes. I said we didn't want to measure the angles differently because then we get thrown off. Do you see how one of them is measuring down from like the positive x and one is measuring down from the positive y? Okay, that's where we start to get in a little bit of trouble. Because both of them aren't measuring standard position in some ways. And they're definitely not working in the exact same angle. So there are a few different ways of thinking about it. Probably the easiest way that you can still use the 30. And if you guys notice, they're doing the whole like, I don't know you and I don't know you, just like we did in our example in the notes. What they did is say, okay, guy, this vector right here, when we're talking about him, we could show this way, I guess. Do you see how this guy is going positive x and negative y? So what did they do? They said 50 degrees has a positive x and a positive y. It's a first quadrant angle. Now this is not a normal 50 degrees. He's going a totally different way. But they say, you know what? We can use the 50 degrees. That's fine, but the x should be positive, the y should be negative. What do you realize they did? Positive x, negative y. Yeah, but look at this. 30 degrees. It's not 30 degrees in the first quadrant. So they said it's negative x, negative y. So the reason why they put positives and negatives is they didn't want to think about how to rewrite 50 degrees to make it in the right quadrant. You could have like added 360, I suppose, to negative. Well, you could make it 310. We could have also said, oh, hey, he's 310. That would have done the same job, just it's harder for a lot of people. And this one you could have done, let's see, what would that have been? 180 plus 30. You could have made this one 210 and not had to worry about all the negatives and positives. But in their mind, they were like, it's easier to just realize positive x, negative y, negative x, negative y. And then do magnitude cosine, magnitude sine, magnitude cosine, magnitude sine. And then what do these both their tensions end up equaling because it's held suspended in space? It's working. The tensions are working. Yeah. It's going to end up, wait, is that thing moving side to side? No. So the horizontal component of the weight would be 0. And then the weight's trying to pull it down. So what they end up doing is saying, okay, if I put the two x's, remember a big old sum, it's not going to work, lo siento. The big old addition, the horizontal component plus the horizontal component must be 0. It's not working side to side at all. And the vertical component plus the vertical component is going to equal that 2,000 that's pulling it down. That's trying to pull it down. So in essence, actually, the tensions would, if I was to show it correctly, the arrows wouldn't be pulling down. The arrows would actually be pulling up because it's counteracting the weight, but that's okay. Either way. And this guy's trying to go down, if that's an arrow. But then other than that, kiddos, it's basically what we did yesterday. In that I would do substitution, solve for one of the guys by adding and then dividing. I would plug into the other one, and then you follow the procedure. Now, they didn't show any of that work. They didn't show any of that math. But where do you go to see how that math is done? Didn't we have a tension one yesterday where we had to have unknowns and unknowns? I made them X's and Y's to make my life easier. I solved for one, plugged into the other, and then moved it all aside. I would go back to that example with your calculator if you haven't yet. See if you understand what I did, why I did it, and then use the exact same idea with this guy that you're trying to solve, okay? So let me give you one more chance for that one. If you do want to actually see the work, come on by, especially before the test, and I can show you like the actual how-to as far as getting one alone, plugging in and solving. But the example in the notes will be the exact same math. Just the numbers are a little bit different. So we did 85, we did 91, we did 96. Are we missing anything? Oh, 101 is the airplane one? Okay. The sad thing is we didn't get to that plane wind one yesterday. But actually, if you guys are looking at your givens, because you should have the picture in your homework, right? If you're looking at the givens, I see a plane with an angle of 148. Nope, that's not the plane, sorry. Yeah, that is. An airplane flying in the direction of 148 degrees with an airspeed of 875. Do you guys see the magnitude cosine angle, magnitude sine angle? Now wait a minute, hold on. Why'd they do 58 instead of 148? They did subtract. What did they subtract? 90. What they were doing was kind of the trick that you guys just saw me do. Is it still there? What they're doing is the trick of they like little baby angles and then doing the positive negative themselves instead of the big angles. What I'm trying to show you really quickly is that you don't have to do it that way. So when you have your picture, you actually could have done the simple plug and chug to component form, and it would have turned out the same way. Because if you had your, they made you the plane, right? If you did the magnitude, cosine of angle, which was 148, the bearing. Then you could have done the wind. Oh, they didn't do the wind. Is that what's missing? Oh, you don't know the wind. Okay. Then you have the ground speed, which would be the U plus the V. Ends up being, I'll get back to it, hold on. Would be 800. Cosine of 140. 800 sine of 140. Remember, guys, the ground speed is the same thing as the U or the plane plus the wind. So what we're missing is V. We don't know him. So if we have the plane and if we have the overall result, we're not going to go adding these two together. How are we going to get the wind? Subtracting. Yeah. We're going to say if that was the overall result, hold on, what was in between? We're missing the V. We didn't know what the V was. Like, who are you? That got added. So we're going to go backwards. We're going to subtract. So the easiest way to get vector V is to subtract, which is what they did. So they went ahead and took the 800, 140 minus 800 cosine of 148. And they would have done 875. 2. 800 sine of 140 minus. So what they did, there should be a side caret. What they did was that whole idea of, we don't like the 148. Can we subtract 90? Can we subtract and do it ourselves? So what you see is them doing like negatives and positives, thinking about where the plane was headed, having to think about the picture. I kind of just like throwing in the magnitude and direction and figuring out later. I think it's a little bit easier. So what did they end up getting for the wind after the subtraction, after taking away the overall minus the jet, the overall minus the jet? Remember, their signs are weird because they were doing those little weird baby angles instead. They end up with 50.55, that you see it, 07, and 129.2065. But the cool thing is, kiddos, once you get the components, Isn't it just Pythagorean theorem? Isn't it just tangent inverse? And then, oh, well, what were they doing? If you do tangent inverse, you end up with 68.6, which the picture would have helped a little bit on this one. And actually, do I still have the picture? I do. If you guys went looking at what was going on, the 68.6 would have put you, here we go, right here with the bearing. The problem was the plane was down here. But the ironic thing is, hold on, I'm seeing if their angle thing would have messed up at all. They did 90 minus in order to be able to get down. Oh, nope, we're good. We're good. Sorry, guys, I forgot. We're not looking for the plane. We're looking for the wind. And the wind really was pushing at that direction. My bad. They went ahead and just put it in a really snazzy notation. Really snazzy notation is you say, when you have north and east, instead of talking about how many degrees this one is down as far as its bearing of a 68.6 degrees, they said that you go 21.4 degrees up from east. That's the northeast. But we never use that notation. So I wouldn't stress too much. They just asked about the bearing with north and east. So I apologize. I got a little weird. I think the 68.6 degrees, this would have been fine. Because you didn't have to add 180. You didn't have to add 360. They were just trying to write it really nice, like with compass notation. So don't worry about that one. 68.6 is good. All right, guys. Those are the last 4 problems. 2 of them were tension. 1 of them was the slope. And then 1 of them was putting everything together. The one time putting everything gets nasty is when you have bearings. But remember, the picture isn't necessarily, for our purposes, as important as working with the components and knowing once you add together, like a jet and a wind, once you add together the components, Pythagorean theorem and tangent inverse. Okay? So a lot of the basic ideas are still there even in the word problems. Priscilla, what's up, kid? I actually have the majority of them graded. I kind of hit a snag that I didn't expect that I have to talk to Dean about. So give me one more day. You guys will get them tomorrow for sure. If I hadn't hit the snag, they would have been ready to go. But give me 1 second as far as to clarify a quick thing about the test. And then you guys will get them tomorrow. I tried to see Mr. Huff this morning and he wasn't in his office, so I need to connect with him later on today. All right, kiddos, here we go. Section 6.4. Vectors and dot products. Vectors and dot products. Thanks for asking, though, kiddo. I wanted to. I was looking, but I haven't gotten back yet. So, section 6.4, vectors and dot products. Remember, 6.3, 6.4, and 6.5 all get to go on the reference page. 6.3 was the worst one, for sure, for sure. However, 6.4 has stuff that you're going to want to put on there as far as the reference page as well. So still keep an eye out, still have possibly highlight ready to go, etc. If you guys notice, this one still has to do with vectors. The last section, 6.5, we're actually going to like barely cover 6.5. We're just going to see just a little bit as to how all these formulas that we've been doing actually does correspond to some complex number stuff, like imaginary numbers, like i's, not the I vector even. We're going to take one day on 6.5. So we're going to do 6.4 today, 6.4 tomorrow, 6.5 on Monday. With a vector test coming next week. That's another reason I'm not totally stressing about getting you guys your Chapter 5 test back. Because I'd rather you focus on Chapter 6. The corrections won't even be due until after the next test because I want you to focus on Chapter 6. I will get them back to you by tomorrow, I'm hoping, as long as I can connect with Mr. Huff. But your main focus is getting through Chapter 6 right now. I totally lost what homework number we're on. Let me freeze the screen really quickly. I can just go back up. Are we on 39? No, we're on 40. Perfect, perfect. Yeah, I won't be doing until Monday because we're taking 2 days on this. The big thing in section 6.4, the biggest thing, is this one formula. Really. Like, I'm not kidding. This one formula. And actually, something to do with this one formula is that the dot product actually equals, it's just a number. Like when you add vectors, you get a vector. When you multiply a vector by a constant, you get a vector. But when you multiply vectors, you actually get a number. And there are all these like properties of dot products, which are okay. I'm not actually going to make you memorize any of these. And to be honest, I don't even think you really need to know them for the test. I'll revisit it, and if I think I do, I'll let you know for your reference page. The most important part is right up here. Do you guys see the components of U and V? Okay, they wrote them the nasty way, the U1, U2, V1, V2. They wrote them the nasty way. But remember, they're just A's and B's of U and A's and B's of V. What does the dot product say? And it's used in all kinds of ways. The rest of the section is literally just like using the dot product and how it's used. It can be used to find all sorts of things. But the formula is pretty basic. It just says take the A components and multiply them. Plus, take the B components and multiply them. Yeah, kind of like x1 times x2 plus y1 times y2, which isn't really anywhere else in math, which is why it's so unique. But if you guys were to be given an example like this one, I just want to show it to you because you can actually get up to like the 20s just knowing how the dot product works. I think in linear combinations it's kind of harder, so I would write it. And I would write it in first. But when we do the dot product, we literally just say, hey, let's take the x's and multiply them, the y's and multiply them. Yeah, literally. So 4 plus 2 is 6. Now, come down here, we'll have to do like a few different dot products, but we could do v with u, the x's, v, u, the y's. That would be this one. Minus, we have to be careful that we don't like kill a seal or something. As we just have to get the hang of the new formula. This one would be w's with v's, the x's, and then w's with. But what are you going to end with? You guys can go ahead and go. I'm just going to do some multiplying, adding. But you can get up to like the 20s in homework, maybe even the 30s, just by saying this guy, the dot product. All right, I'll figure out his formula. And I'll see you guys later. Bye. Someone's not watching the video, they won't get that. Bye, guys.